Okay, we are going through the topic of travel time studies, which are also called as journey time surveys. So we discussed why do we do travel time studies, how can we do them, there are different methods for it, and one of the method, very useful method is the test card method. I showed you some examples of the data collected with the test card. You are going through the examples, the analysis, and uh, as I mentioned earlier, that there are no new equations for travel time. We are using the same equations which we have used for the others, the spot speed studies. Okay, so there is no such equation as the sample size of travel time data. It's the same equation which we have already used for spot speed data. Okay, and same thing for mean and 95% confidence interval and so on and so forth. Okay. So in these examples, we calculated mean, standard deviation, 95% confidence interval, and the sample size for the travel time data using the same equations which we have seen for spot speed. The only new thing which we saw here was that in the spot speed data case, we had the frequency distribution table. Okay. So in the last lecture or the lecture before that, we looked at the bar diagram. Okay. So you can use the values of the bar diagram in the same way you use the value from a frequency distribution table to calculate the mean and the standard deviation. And then we saw how we can calculate delay as well. We're looking at this example. So again, the data is given from a task card method. So we can see the values are given for each section, cumulative distance, cumulative time, and the delay of each section. And we were doing some calculations for it. So we are section 1 to 2, 2 to 3, 3 to 4, 4 to 5. Okay. The travel time which are given were cumulative. Okay, so we already calculated the travel time for each section. So for the first section, it was already 2 minutes 05 seconds. What was it for the second one? We did it in the last lecture. How much was it? 245. Yes.
240.
Next.
140.
And
117. 127.
Okay. Then we are required to calculate the running time as well. What is the difference between travel time and running time?
Without delay. So without delay.
With delay. Okay. So I asked you to subtract the delay. The delay is already given for each section and calculate the running time. So the first one will be how much? 215. So subtract the delay.
155.
Okay. Next one. 215. Next.
215.
Again. 215.
58. 30. 130.
No. How much for this? One how much? 13.
30.
Okay. Now I'm supposed to calculate the speed for each section. Okay. So for speed, I need time and what? Distance. Okay. Again, if you see here, the distance is given cumulative. Okay. So I will again subtract it for each section. Now called L in miles. Okay, for the first section, it's 1 mile. Okay, between point 1 and 2. Next one, 1.25. From 1 to 3, it is 2.25, and 1 to 2 is 1. So you subtract it, get 1.25. Next, 1.25, 0.5, 0.25. Okay, last. Okay, so cumulative values were given, just took the difference. Okay, clear? Any problem till now? Okay. Then using these values, I will calculate the travel speed and the running speed. Start with travel speed. I want the value in miles per hour. Then the running speed, miles per hour. Okay, so speed is distance upon time, right? So distance 1 mile. Now the time is in minutes and seconds. Okay, and I want the speed in miles per hour. Okay, so if it is 155, so 1 divided by 60 plus 55 divided by. Okay, for the conversion. Sorry. How? How? One is in minutes, the other one in seconds. So. Yes. We have to do something before this. Either convert the entire value to minutes or entire value to seconds then. But still you will be doing 2 steps, right? Okay. Next, you will take the length and the travel time for the second section now. How much? Next.
Okay.
28 point.
18. 11.7. 13.
Okay. For the running speed, what will change? The time. Huh? You will take travel time now. No effect on the distance. So how much? Sure. First one is how much? Running speed. Running speed. Cannot be the same, the time is different. $21.8. Which one? These two will be same. The distance is same, the time is same. How much is it? 21.8? Okay, next. Hmm.
For the time speed,
Time speed is
shouldn't we use the
Travel
travel
speed.
time?
2 plus 2 over 60 plus 5 over 3.
Hmm. What did we use?
We use
Yeah.
speed.
Huh?
Running time.
We use running time, all of them?
No, I don't think so. Only the first one.
Only the first one? Okay, how much is it for the first one? So this one is here.
Rest is correct, only the first one.
Hmm. How much is this? This is 28.3, 28.8. Okay, what about this one? So 0.5 miles upon 58 seconds. How much? Huh? 58 seconds.
Plus 58 or
Mhm.
Yes, it's fine. 31.
What about those values? Are they for running time or travel time?
These are for running time.
No, those, which we already had.
That one for running time.
No, these ones, which I already wrote here. These are for travel time or running time. Check this. This is for which one? So this is 0.5 upon 1 minute 40. How much you will get?
18.
18. Okay, and how much we are getting now? 0.5 upon 58 seconds. How many?
31.
Okay, check these two.
33.3.
Okay,
Same.
same. Okay.
31.03.
Which one?
That
That one is 0.
03. 30.
I can give you as many zeros as you want.
37.
Okay. Hmm. Okay. So you can see which one is higher. Running speed is higher, right? Can running and travel speed be equal? No? Never?
Not here, but here also.
Here they are not equal, but if they are equal, they can be equal
Yes.
Yes. if there is no delay, right? But can it be the opposite? That travel speed is higher? No, right? Okay, they can be equal or running speed can be higher if there is a delay. Clear? Clear? Okay. Then we have the plot, obviously, travel time, which we calculated for each section. It was given cumulative. Okay, so this is for each section, and the delay which was already given for each section. Okay, so which section has a problem here? Which section has a problem? Why? More delay. Okay, so problem is not because of travel time. Problem is because of delay. Okay, if you look at the travel time, which section has the highest travel time? 2 to 3. Okay, and the reason is it has more length as well. It has the highest length. Okay, so obviously it will take more time. Okay, and the same thing is shown here by travel speed and running speed. So you can look at their difference. The difference between the travel speed and the running speed. Okay, so if you look at the difference of section 5 to 6, the difference between the two values is the largest. Okay, so that shows the problem with this section. Okay. Now let's say they want to do another study using test cars on the same section. Okay, so they want to they will hire test cars like they did in this case, and one car is available for 5 runs. Run means what?
Just,
Huh?
just, like,
Test?
yes.
Test? We had a test yesterday. That test?
Experimental time.
Time?
5 times to make the experiment. Yeah, observe.
Samples?
Yeah, observations.
Samples, observations, okay. So each car will make 5 observations. Each car will make 5 observations or 5 samples. So they are now asking how many vehicles should they hire in total. Okay. So then I should know how many runs I need, how many samples or observations I need. Okay. So for this, we will use the same equation which we have used even in the last lecture and before that in the travel time, in the spot speed case. Okay. Okay. So they are saying one vehicle will make 5 runs. So what are these values? The other values which are given in the question. What are these values? Sorry? No, the values which are given in the question, what are these? Which one is error? The tolerance is error, okay. 95 is what? Confidence interval. So where do I put it in the equation? This is my equation, right? So where do I put the confidence interval in the, or confidence level in the equation? Where is it? Yes. 2 to 3 1. Where is this 95 in the equation? Where should I put it in the equation? S? So where did it go? I'm putting the value of E, right? And E is how much? 3, right? So where did this 95 go? It went somewhere, right? Huh? Where is X for? What is the use of this 95 in this equation? Simple question. Which one? 3.84 is because of 95%. This 3.84 is because of 95%. We don't put 95%. 3.84 is because of 95%. Okay? We don't put 95 anywhere in the equation. Okay? There's a small sound of S here. No. Okay? There's no. The other equation we had was with 9. Instead of 3.84, it was with 9. And then the confidence level is 99 point something. Okay? So this confidence level doesn't go in the equation directly. This constant changes because of my confidence level. Clear? Clear? Sure. Okay. So I need what now? What do I don't know? No, that I want to find out. But what do I don't know right now? Standard deviation I don't know. Okay, so I have, if you look at the value of error, it is given in miles per hour. Okay, so if E is in miles per hour, then S should also be miles per hour, right? Okay, so then it means that I need the standard deviation for the speed samples or the speed values. Okay, now I have 2 types of speeds, right? Travel speed and running speed. I need for both. I'll do it for both. Okay, so now if you look at the data, okay, so I will use this equation for standard deviation. Okay. So in this case, we are not using the equation which we use with the spot speed data, because the spot speed data had the frequencies. Okay, there are no frequencies there. Okay, so I cannot use that equation. So I'll use this one, which is used for the data which doesn't have frequencies. A simple set of values. How many values I have for travel speed? How many values I have? 6 speeds, right? 6 values. Okay, so whenever you just have values without frequencies, we use this equation for calculating the standard deviation. Clear? Okay. And some of you have very low number of values from the first submission of the term project. Okay, because I said you have to collect 10, so some of you did 10 or 11, which is fine, no problem. Okay, but don't try to make frequency distribution table with those 10, 11 values. Okay, it will not have any benefit. Okay, like how many values you can have in different groups. Total you will have 10 or 11 values. Okay, so use this equation to calculate the standard deviation. Okay, if you do 50 cc value, fine, make a frequency distribution table and calculate the standard deviation like we did for the spot speed data. Okay, but with 10, 15 values, no need to do this. Let's use this equation simply. Okay, so x is my value. Okay, value of the speeds which you see here. X bar is what? Average. Okay, so you would calculate the average of each of these columns. And what was capital N? Total number of value, which is 6 here. Okay, so let us do it for the travel speed first. So give me x bar.
24.14.
Okay, now give me s. There's a summation here. Okay, so each x or each value of travel speed minus the mean, okay, square summation. Huh? What is that? I will show running speed. Okay, then we can calculate n now for the travel speed.
24.14. 25. The bar of some place.
Yes. Standard deviation for running speed. What? Nothing.
2.5.
Okay, then the n. Yeah.
Can't be around
Why?
2.6. Raise up, please.
You decide. Okay. So in the first case, how many values we will take?
25.
25. Okay. Can we make it 24?
No.
Reason? What's the reason?
More accurate.
Huh?
More accurate.
Yeah. Okay. So this 24.5 has an error of 3. If you take less than that, then your error will increase. So I cannot do less. I can do more, so my error will decrease. That is acceptable. Okay. Less error is acceptable. More error is not. Clear? Clear? Okay. And in the second case, I'll take 3. Okay. Now in the first case, the question was how many vehicles should be hired if each vehicle will do 5 runs. So in the first case, how many vehicles? 5. Okay, you will hire 5 vehicles. Each vehicle will do 5 runs. So in the end, you get 25 runs, 25 samples. In the second case, 1 vehicle, but that 1 vehicle can go up to 5 runs. Okay, so you can actually take 5 observations. Your error will be even lower. Clear? Okay. Any questions? Okay. Now one thing which you should keep in mind, that standard deviation is always less than the mean. Standard deviation is always less than the mean. If it is the other way around, then you have a problem. Either you have a problem with your calculations or you have a problem with your data. Okay? Either you did not calculate the standard deviation properly or you did not collect the data properly. Both of them have a problem.
What do you mean you didn't collect the data?
Maybe you made a major error in writing the values, noting down the values, observing the values. Some big problem with the value, some big mistake with the value. Okay, for example, writing 31 when it was 13, something like this. Okay, so these type of mistakes, the writing mistakes or missing values, they can cause this type of an issue. Okay, but the general rule is standard deviation should be less than the mean. Okay, now which one has more standard deviation? Travel speed, right? Travel speed has higher standard deviation. That means that this data has more variation. Okay, so what's the reason? Yeah, travel speed is lower, running speed is higher. That is understandable, right? Because this is because of what?
The speed,
But
no speed.
no. Yeah. That's a. What is the difference between travel speed and running speed? The difference is because of delay. Okay, so delay is causing the value to decrease, the speed value to decrease. That is understandable. Okay, but why it is causing more variation in the data? Delay is not only reducing the value, delay is also causing more variation in the data. Any reason why? Sorry?
Not all the vehicles have the same delay.
Okay, anything else? This is for
Reasons of delay is different. Reasons of delay is different.
reason of delay is different. What else? Remember, this is
Delay is
just
not con-
one data. It's not for all travelers.
It's not constant number. Delay is not constant number.
These reasons are correct if you are looking at data of like 100 travelers. This data is not for 100 travelers. This is it was one set of values, right? Each section, one value, each section. Like this, right? So delay causes more variation in speed because of stopping and starting. Delay means what? You will stop. You stop, your speed is 0. And then you start again. So you go up to 20, 30 again. Okay. Then you may have to go back to 0 again. Okay. So delay causes you to stop and start. This stopping and starting will cause more variation in the speed because you are going from 0 and up, 0 and up. Clear? Okay. So that's why you see more variation in speeds, which has more effect of delay. Okay. Then when we started this topic, I mentioned that one of the uses of travel time data is to plot travel time contour map. Okay, so this is an example of a travel time contour map. You see, instead of contour lines, we have these contour bands. Okay, so it's not actually a thin line. You can see it's a solid flat band. Okay, so these bands provide travel time from a reference point. Okay, the points which are joined by these bands are showing a specific travel time or having a specific travel time from the reference point. Okay, so for example, the first band, which has a travel time of 15 minutes. So any section which is on this band has a travel time of 15 minutes from the reference point. Okay, and then you have this outer band which has a travel time of 30 minutes. So any section which is on this band has a travel time of 30 minutes from origin or reference point. Clear? Okay. Now what we have seen in the examples up till now, we had the data for sections. Okay, sections on a highway. In this example, there were 5-6 sections on the same highway. Okay, so this data of one section or one highway is not enough to make a travel time contour map because you need distance and time in all directions, right? So if you did it on one highway, like let's say I did the survey on this highway, so I will only have travel time in this direction. What about the other directions? Okay, so just doing it on one highway or one section is not enough to create a travel time contour map. You need to get the data for an entire area. You need to go from your reference point in all possible directions. Clear? Okay. Secondly, why do we use these travel time contour maps? We use them to find out the catchment area for our reference point. Okay, the catchment area for the facility which is at the reference point. What do we mean by catchment area? Number of people in the area, population of the area. But that will be then catchment people, right? Or catchment population. What do we mean by catchment area? Where else have you heard about this term? Water supply. So what does it mean, water supply? This is my catchment area. What does it mean? Area for which you design, right? Okay. So area which you are going to serve with your pipeline in that case, right? Same thing here. The area which we are expected to serve by this facility. Okay, so there is some type of facility. My reference point is some type of facility. Maybe a hospital, maybe a superstore, maybe a restaurant or something. Okay, so this travel time contour map tells you from which area are your customers, you can expect your customers. Okay, so usually when we make the decision about where to go to buy something or to take something or to go for gym or sports or something, how do we decide about it? We decide on the basis of travel time. Okay, we decide on the basis of travel time. Okay, so if you have to go and buy a bottle of milk, okay, then you will definitely look for something which is within 5-10 minutes of drive, right? If you are going for the monthly grocery, okay, you will look for a bigger store, and then you may look for something which is maybe 15-20 minutes of drive, right? Okay, so you decide about the facility which you will use on the basis of how much time it will take to get there, right? How much time for the airport? Huh? 10 minutes. Huh?
No, not 10 minutes.
10 minutes you will reach the airport if you fly. Okay. Anyways, so you get the point. Okay. So if this, from which area people are more likely to come here? This area, from this area they are more likely to come, right? Because this area is closer. Okay. If you go outside this band, the possibility is less. And if you go outside this one as well, then the possibility is even low. Okay, so we will look for, okay, how many people are here, okay, which are more likely to use this facility. We will design the parking, we will design the roads, we will design the facility according to that, okay, according to the catchment area. Okay, clear? Yeah, for airport it can be 1 hour as well. Seriously, yes. Go if you want to. Like you want me to stop? You want to go? Go. No problem. Yeah. I know you. Okay. This is another way of representing travel time data, which is the time distance diagram. So in a time distance diagram, you plot the time and distance of your test vehicle, test car. Okay. So you are sitting inside the car and you are noting down the time and the distance covered by the car. Okay, so that will become the coordinates of this diagram. Okay, so in 30 seconds, the car reached this much distance. In 1 minute, the car reached this much distance, and you are noting it down. Okay, and then you, once the run is done, you will plot these points and you will get something like this. Okay, clear? Now you can see somewhere the line goes vertical. At some points the line goes vertical. It means what? What is happening here? Why did the line go up and not forward? What do we have on the y-axis? What do we have on the y-axis? Time. Okay. And what do we have on the x-axis? So vertical line is what? Delay. Okay. The vehicle is stopped and the time is moving. Okay. So you can measure the length of these vertical portions and you will know how much delay is caused in different sections. Okay. One axis is time, the other axis is distance. So time and distance can give me what? Speed. Okay. So you can calculate speed for different sections. Okay. So you can calculate speed. How much is the speed here? How much is speed here? How much is speed here? Okay. So you can calculate speed for different sections. But if you take total time and total distance, it will give you average speed. Okay. So total time upon total distance upon total time will give you average speed. Okay. So you see they have plotted a dotted line for the average speed. Okay. So for example, the average speed was 24.5 miles per hour. When they did total distance upon total time, they got 24.5 miles per hour. Okay, so how do I plot this line? Using the average speed, I'll calculate how much distance the vehicle is supposed to cover in 30 seconds and 1 minute and 2 minutes and so on.
Can you
Okay.
repeat this?
Sorry?
Can you repeat the last point again?
So your average speed is 24.5 miles per hour. So if the vehicle is going at 24.5 miles per hour, how much distance will it cover in 30 seconds? This much. So I might make a point here. How much distance it will cover in 1 minute? This much. How much in 1.5 minutes? How much in 2 minutes? So I will get the distances in different times at this speed. And then I make them, I join them, so I will get the line for the average speed. Clear?
Space means speed.
Huh? Space mean. Clear? Clear? Sure. Okay. One thing again which I mentioned actually in the last chapter, that we do intersection delay studies. How? Which technique do we use for intersection delays? To measure intersection delay. We have 3 types of techniques, right? 3 types of studies. manual,
Semi-automatic.
semi-automated, fully automated. Which one we use here?
Automatic.
Huh? We use automated? No, we use manual.
Manual.
Okay,
Yes.
intersection delay studies are done. Yes, now you know. Intersection delay studies are done manually. Okay. Why do we do intersection delay studies? Delay is more important than intersection because intersections by design have delays. Okay, intersection are designed to have delay because you stop the vehicles at the intersection for safety reasons. Okay, you cannot have people just entering the intersection without a stoppage from all sides at all times. Okay, when we design the highway, the segment of the highway, we don't design for delay. We design for continuous movement. But intersection design is done for stop and move, so that everybody can get a chance. Clear? Clear? So that's why we do delay studies at intersections. Okay, because intersection then is necessary part of intersection. Delay is necessary part of intersection, and that it serves as a measure of effectiveness. Okay, so we know all intersections will have delay, but the intersection which is better than the others is the one which has less delay. Okay, it will not be zero, but the one which has lower delay is better than the others. Clear? The delay which we have seen in the examples up till now, all of them were stop delay. When the car is stopped, we call it delay. Okay, but that is stop delay. On intersections, we are not interested in stop delay. We are interested in something more, which we call as control delay. Okay, and there is another word for it which we will learn later. Okay, so control delay is something more than stop delay. Control delay includes three things. Control delay includes the time in queue, the deceleration, and the acceleration back to normal speed. This term ambient means normal, the average speed of the road, normal. Okay, you are coming towards an intersection. You see the signal is red. There are 3-4 cars already standing there. Okay, so before you reach these cars, you will start to decelerate. So this deceleration is part of control delay. Then you will join the queue. So the cars are stopped and you are stopped behind them now. Okay, then they start to move, but you are still in the queue. You are moving, but in the queue. This time in queue is also part of control delay. Okay, then once you clear the intersection, the queue is gone. So now you try to accelerate back to the normal speed. So this time of acceleration is also part of control delay. So it has three things. Okay, the moment you see the intersection and the queue, you start decelerating, your control delay starts. Then you will join the queue, you will move with the queue, until you get back to the normal speed. It's all controlled delay.
How do you collect data from this?
Yeah, I will come to it. Okay, the measurement of control delay at signals. Okay, we follow a procedure which is given in Highway Capacity Manual of 2000. Okay, 2000 the year. Okay, so this method requires two observers, two people for each direction. There are different directions on the intersection, right? Every direction needs two people. Every direction needs for delay measurement two people. Okay. Before you start the study, you have to make sure there is no traffic jam at the signal. So there is a delay because of signal, and there can be a delay because of traffic jam on the signal as well. This should be additional, extra. So I'm just interested in the delay because of the signal. Okay. So we have to make sure about two things. The queue is not very long at the intersection. So you come, you see how many cars are in the queue. If you see 50 cars in the queue, there is not a good time. There is a traffic jam time. Okay, you can come later on. Okay, so they have given us a range. If the queue goes more than that, don't do it. Yes.
Per lane or for the whole section?
As for per lane. Okay. The second indication of traffic jam is overflow. Okay, overflow is when the signal is red, it becomes green, but you are so far in the queue that till the time you reach forward, the the signal becomes red again. Okay, happens, right? Always, very good. So give sadaqah before we start. Okay, so this is also an indication of traffic jam. So make sure the queue is not long, and make sure that the overflow doesn't happen often. Yeah, you can be one driver who has nothing to do with life. It can happen with them. Okay, but if it is happening regularly to the queue itself, then it's a traffic jam. We don't do it in those conditions. Before you start the study, you must find out the free flow speed. For free flow speed, we do the spot speed studies. Now the problem with spot speed study at the intersection is the cars are stopping, right? Okay, so if you do the spot speed study at the intersection, then you can only do it during the green time without queue. So if 100 cars come, but many of them are coming during yellow or red, you cannot take the speed of those cars. Some cars are coming during green, but when they come, there are already few cars in front of them. Again, their speed is not free flow speed. Only those cars which come during green, no queue, they just keep on moving without stopping or slowing down, those cars will be counted. Those cars will be taken or observed for speed. Okay? So you can do spot speed study on the intersection in this way. Another way of doing a spot speed study is you go behind the intersection to a point where the queue is not yet formed. Okay, so the queue is up to this point and I am 100 meters behind it. So I do this spot speed study at a point where there is no queue. Okay. My apologies in advance, I will take a couple of extra minutes because we have to go till the other section. Okay. We have two observers, right? Two observers. Observer number 1. He is noting down how many cars are in the queue after a fixed interval. You give him an interval. Okay? Interval of time. So, and that interval of time is between 10 and 20 seconds. Between 10 and 20 seconds. So, after, whenever this interval passes, he will look at the road and he will see how many vehicles are in the queue. He will count it, note it down. Okay? How to select the interval? I told you 10 and 20 seconds. And this interval is selected on the basis of cycle of the signal. Cycle means what? From the start of one red to the start of next red. This is called a cycle. So red, yellow, green, yellow, and when the next red starts, this is one cycle. Start of one red to start of next one. Okay? So your cycle length should be a multiple of the interval you are giving to this guy. Okay? So for example, cycle length is 60 seconds. Okay? You can give him an interval of 15 because 60 is a multiple of 15. Okay? But you cannot give him 13 because 60 is not a multiple of 30. Okay? So whatever interval you give him between 10 and 20 seconds, cycle length should be a multiple of that value. Clear? Now he is counting what? People who are in the queue. Queue means what? If you are going straight, anybody behind the stop line is the queue. For a straight movement, if you are doing it for a straight direction, then anybody behind the stop line is in the queue. Whether they are moving or stop. Your signal is green, but they are still behind the stop line. They are in the queue. Okay? If this guy is doing it for the turning, okay, then anybody behind the other direction is in the queue. So they already crossed the stop line, but they are turning. And they did not reach the other side yet. So even the turning is in the queue. Okay? He is counting number of vehicles in the queue. Who will he count? If he is doing it for straight, anybody behind the stop line. If he is doing turning, then anybody who did not reach the other side yet. Clear? Okay. Last thing about this guy is that we hate him. We don't like him. Okay? Like he was the last person in this class, we had to make a group with him. One thing. Okay? So, what do we tell him? Are you making faces? Huh? She's thinking about something. Okay. So, what do? We ask this guy, okay, the study will finish. So at the end of the study, you still have some cars in the queue. You will not leave until these cars are gone. So your study will continue. So let's say the initial time of the study is 10 minutes. 10 minutes, the others are gone. But at the end of 10 minutes, there are 3 cars in the queue. So until these 3 cars go, he will keep on taking observations. So if these 3 cars take 1 extra interval, he will do it for 1 extra interval. If these 3 cars take 2 extra intervals, he will do it for 2 extra intervals. Okay?
How about other counts also?
No, no. We don't be hating, but we don't want to kill him. Okay? So we are only focusing on these cars which came during the study time, which want them to leave. Okay? So we ask some friends to come there and don't leave. Okay? Now, the other guy, the second observer, is noting down 2 things. No interval for him and no extra time for him. He is noting down how many cars come and how many of them stop. That's it. How many cars come to the intersection and how many of them stop. So when the study is finished, he will give you 2 numbers. In these many minutes, 100 cars came, 80 of them stopped. That's it. Clear? Okay. Any questions?